Hello everybody, this is Vivek. I'm your chemistry tutor and I'm here with another problem in chemistry. Today the topic that I've chosen is equilibrium and we have the problem already on the screen and let us read the question. When 2 mole of phosgene, that is CuCl2, is put in empty 1 liter flask, this is important, at 395 degrees Celsius. This may be required, may not be required, we'll see that. And allowed to come to equilibrium, the final mixture contains 0.0398 mole of chlorine. Okay, and we are supposed to find Kc, which is the equilibrium constant. So now let us understand what has been given to us. So we have been given the moles of COCl2, which is 2. Then we have been given the volume of the container, that is 1 liter. Then we have been given the temperature, which is 395 degrees Celsius. Comes to equilibrium and final mixture contains 0.0398 mole of chlorine. So we have mole of chlorine. So N of chlorine, that is 0.0398 mole. Okay, that is at the equilibrium, the final mixture. Okay, so in order to solve this problem, let us first write down the decomposition reaction of phosgene. So the decomposition reaction is COCl2 is broken down, so basically in equilibrium, to form carbon monoxide and chlorine. So this is the reaction that takes place. Now we will use the ICE table to solve this kind of question. However, to solve the to solve the problem that are based on ICE table, we need concentrations and we have been given moles. However, we know that concentration is N over V. Okay, and in our case, the V is 1 liter. So whatever is the mole, that will be our concentration. So this particular information will be extremely critical. In this particular problem, we don't have to solve it because our volume is 1 liter. So whatever is the mole, that will by default be the concentration. I hope this point is very clear to everybody who is going to solve this kind of problems. Now, if your volume changes, then you need to use this equation, find out the concentration and use it in the ICE table. So what is ICE table? So ICE table is initial concentration. So initial means when the reaction starts. So when the reaction start, we have, so I'll write here moles per liter so that everybody is clear that the initial is concentration and not moles. So the initial concentration given to us would be 2 moles per liter. Since the volume is 1 liter, it is 2 moles per liter. And since the reaction is at the start, we don't have any product. Okay, then what will happen is this particular initial equation or the reaction will proceed and there would be change. Okay, and what would be that change? That we don't know. To be honest, we don't know what would be the change. So what we'll say is, we will say that let us say the reactant reduces by X, and that is the reason I've put minus X. That means we will have the product that is plus X and plus X, because 1 mole of COCl2 is broken down to 1 mole of CO and 1 mole of chlorine. So if X of it is reduced, definitely plus X of CO and plus X of Cl2 would be formed. So now again this would be in mole per liter, and then we have the equilibrium concentration in mole per liter. So that would be 2 minus X, this would be plus X, and this would be plus X. Okay, now why this is ICE table? Because we have initial, we have change, and we have the equilibrium. So we know that the equilibrium is K is concentration of the product over concentration of the reactant. Okay, therefore we will have Kc as concentration of the products over concentration of the reactant. Okay, therefore we can say we will have this as 2, sorry, this would be, so we will have this as x, this as x, and this as 2 minus x. Okay, now we have been given, if you remember, we have been given the final mixture contains 0.0398 mole of chlorine. So we have been given 0.0398 mole of chlorine. And since we know the volume is 1 liter, we can say the concentration is already known to us. That means the X is known to us. That is 0.0398. So what we will do is we will substitute that value over here, 0.0398 0.0398 over 2 minus 0.0398. So if you solve this, you will get 0.00158 over 1.9602. And if you solve this, you should get 0.00080. So the Kc value you can write as, so you can make it to decimal 1, 2, 3, 4. You're moving the decimal 4 times towards the right hand side. So you can write 8.06 into 10 raised to minus 4. Remember, we moved the decimal 4 places. That is the reason we will get it as minus 4. So the Kc value would be 8.06 into 10 raised to minus 4. That's all for today. Thanks for watching. If you want me to solve any questions, please put those in the comment. Thank you so much. See you next time. Bye bye.